Probably we have a few people from Ukraine here. Not a surprise. Peter, nice to see you, joining us from Austria and representing us in Germany. Oh, we have even somebody from USA. Glad to see you here. Hossein, it's also nice to welcome you from Algeria. So I think we can slowly start. So let me also open my screen. One moment. So do you see the screen of this presentation? Somebody please say me yes.
Yes.
Good.
Yes, but it is not in a full screen mode.
Yes, it should be. Is it now?
Yes.
Great. So, dear partners, dear colleagues, we are very glad to have all of you gathered here today. Our topic today will be about mycorrhiza, one of the most popular biological product in the industry, because even in some markets where biologicals are not yet so much widely used, a lot of people already hear about mycorrhiza, and not only in professional segment, but also in home and garden. So today we will speak about a few things concerning Mycorrhiza. I will start with a very small introduction of the company, also following by some market information about Mycorrhiza in the world and in different regions with some trends as well. After that, we will invite some of our scientists and experts to share some information about the history of Mycorrhiza and also kind of Mycorrhiza qualities and properties, especially those which are so beneficial in agriculture. And after that, we will follow with practical part with our technical department, and we will share our wide and deep expertise with application of mycorrhizal product because going ahead we have more than 400 studies with mycorrhizal product in very different zones, areas, crops, and we will be very glad to show that experience to you. Also, we have here some international experiences. So if you see some of your own trials, we invite you to say a few words as well. So let's start. So first of all, for those who don't know us yet, we are a company from Ukraine, the biggest producer in East Europe with more than 500 people, covering more than 4 million hectares each year with around 60 biological products. And we have a big database of trials, more than 2,000 of them, from which 90% are successful with average 10% increase of the yield. What is important, we are now working to update this database because we didn't do it for 2 years, and we expect this figure to be more than 3,000 quite soon. And we will, of course, share this data with you. So then again, we are the biggest in our region and among the biggest producers in the world, part of IBMA, Biocontrol Manufacturers Association. Company is already 27 years old. We also have office in Germany, somewhere here. And we collaborate with a lot of scientific institutions around the world to prove efficacy of our products. At the moment, you can find us in 25 countries around the world already, starting from Peru and up to Japan. And the strongest positions we have in Central and East Europe. In another 40 countries, we are performing studies, and I hope that some of the participants of today, especially from North Africa and some other areas, will join the list of our partners. And in general, in Europe, we have at the moment more than 20 products registered, including 2 formulations of mycorrhiza. So this is how a production looks like in the west part of Ukraine. We work in quite a big scale, able to cover millions of hectares. We have special conditions to work with microbial products to provide their clearness and efficiency. We of course work with hundreds of own strains. This is our office in Kyiv, which we plan to start maybe till the end of this year, and our office in Germany, and part of our team. By the way, you can see somebody from you on our last year international partners meeting here. And we are quite active in the industry, participating in main industrial events as Biostimulants Congress, BioG Congress, ABIM. By the way, next BioG Congress will be in Valencia in 3 weeks, so you're welcome to visit it and to see us there and other industrial events. And we try to be the best partner for you with helping you to register products, prepare your technical specialist to work with them, do certifications, studies, trials, help you to find how they work and to show how to see that the product works and provide ongoing development support. So from that, let's come closer to the topic about biologicals, market, and mycorrhiza. So first of all, it's important to understand that mycorrhiza is a biological product, and biological products market at the moment is around 15, 16 million billions dollars, and it consists of mainly three categories: biocontrol, biostimulants, and biofertilizers. So we work with most of these categories. If we speak about mycorrhiza, normally it refers to biofertilizers. So at the moment it's up to $2 billion as well. You can see also that biological market grows quite active, around 10.5%, and it's going to nearly double until 2030. And we feel it from our growth as well. So coming closer to mycorrhiza, there are different assessments of size of the market of mycorrhizal products. It's somewhere around 500 millions dollars and $1 billion. So it's big part of biofertilizers, but if we take all biological products, it's still not the biggest part. Speaking about the crops on which mycorrhizal products are applied, again from some available sources, we see that big part of it is row crops, and horticultural crops and high-end crops is a smaller part. But in reality, especially in Europe, we can observe that a lot of farmers apply mycorrhizal product, for example, in greenhouses, in nurseries, and most of them hear about mycorrhiza because it's very good for roots development, rooting in general, and for small plants. But this segment of the market is comparatively small if we compare it with millions of hectares of arable crops like corn, sunflower, wheat, etc. So, speaking about East Europe, in our experience, we work mainly with raw crops as well, but still, again, we will show you some examples, and it have a quite good perspective to apply in horticulture as well. So, speaking about some trends on the market, we again see that expansion of raw crops application of mycorrhiza is going on, and we see it because again now some farmers look for tools to address drought tolerance. Some farmers look how to optimize nutrition and how to, in general, increase economic efficiency of their technologies. That is why in row crops, especially in Europe now, more and more farmers are open to mycorrhiza application. Then speaking about uh, formulations, we also see that more and more interesting formulations are developed. Uh, Mainly, it's quite difficult technologically to have a liquid formulation of mycorrhiza because normally they have some insoluble particles, but still some formulations are available, including BTUs one. And now again, I just returned from USA BPIA conference in Washington, D.C., where also met with some industry players, and I see that so-called planter box products are quite big popular already, and there are like tens of different products with micronutrients, also with microorganisms to be applied to the seed boxes. So we also have such experience with MicoFriend, and today, after my colleagues will share this experience. So then what we see, the integration of Mycorrhiza to some complex products. It's also not always easy, but it's quite sufficient. Because of mycorrhiza properties, we have seen and worked with some ecological projects for some remediation of the territories. We also collaborate with some fertilizers producers or kind of soil mixtures who want to enrich these solutions with something special. In this direction, we work with mycorrhiza, and also we work with some phosphorus solubilizing bacteria as well. Other trend is working about on the shelf life, because again, working in international like wholesaling system, we understand that biological products need to be stable at least for 1 to 2 years in normal conditions. That is why industry is working a lot to stabilize the formulations to be capable for normal distribution chains. So we are again glad that we already are quite ahead in this question, especially with dry form. Then again, companies are working on technology of production of mycorrhiza, because again, it's quite sensitive and uh, kind of difficult to organize production of mycorrhiza in a traditional way in big scale. That is why we also try to use all modern approaches to have efficient but also economic formulation of mycorrhiza. And of course, there are a lot of studies to understand how mycorrhiza is working and how specific mycorrhizal products are performing. That is why, again, we collect hundreds of studies and see what are the limiting factors of work, etc. And just to finish with some example, there are some studies available in science about overview of different biologicals product efficacy. And you can see that in this study, arbuscular mycorrhiza is one of the most kind of consistent in terms of yield response, and with big increments to the yield. Speaking about other places of analysis, we can see that also mycorrhiza is quite consistent in terms of soil properties where it is applied. The most efficient it is with kind of low average amount of phosphorus available, but it does not decline so much even with higher phosphorus availability in soil. Then we also can see that also in different phosphorus availability, we have different yield response, but most of them are positive. Same we can see about organic matter, that mycorrhiza performance is positive even in pure soils, which have quite low organic matter, but also it works with good quality of soil. And speaking about the pH levels, also interesting in these studies that even though mycorrhiza as a fungi prefers lower, more acidic neutral pH, we have plenty of examples where with high pH, almost 8, it have a positive plant response. So similar to this, we probably a lot of you already know, we have this database of studies with more than 2,000 studies in it. And mycorrhiza have a strong place in this database. Maybe it does not have the highest yield response, but we work with field crops such as sunflower and corn, where these 6-7% are quite sufficient in terms of yield. And you will see these examples. And also one of the directions of application of mycorrhiza is co-inoculation of soybeans and legume crops. And you can see that you can see quite good jump of performance here as well. So this is all about my short introduction. And on this, I would like to give a word to my scientific colleagues, Vera Vitalyevna Borodai and Yaroslava Bohotska. Just a moment, and I will ask my colleagues to open the presentation. See the presentation, just please open the full screen.
Yes.
One moment.
Hello, everyone. I would like to share with you some interesting facts about history of mycorrhiza, discovery, and the start of the commercial production and application. And next slide, please. And the history of mycorrhiza research encompasses the discovery of three key types of symbiosis. First, the ectomycorrhiza in tree species. The second is endomycorrhiza in herbaceous plants. And the third is specific mycorrhiza in orchids. And understanding the versatility of this symbiosis became the basis for the creation of modern mycorrhizal biological products effective for agriculture crops, ornamental flowers, and forest plantations. Next slide, please. And first period was descriptive, and the story of mycorrhiza starts with monotropa. This is non-photosynthetic plants, and Curtis and Hooker from United Kingdom in 1828, they describe this mycorrhiza on this plant. Next slide, please. And later in 1832, Elias Fries initially recognized fungal structures on the outer surface of monotropa roots and named this fungus. And in 1840, Theodor Hartig drew and characterized structures on pine roots, and intraradical structures were named Hartig net years after Theodor Hartig discovery. And František Kaminsky in 1882 and other observed similar structures on trees. Next slide, please. And in 1885, Albert Bernhard Frank from Germany conducted a 3-year experiment that provided the first proof of the beneficial role of mycorrhizae. And Frank introduced the word mycorrhiza 141 years ago. Next, please. And endomycorrhiza scientist, very famous Frank Gallo in 1904, Ernst Isidor Gallo first described fungal structures with hindplant roots, such as arbusculus, and he drawing of different endomycorrhiza types. You see it on the left side, you can see on the right recent corresponding photomicrographs. This is in 2021. Next slide, please. And Noel Bernard from France, the famous discoverer of symbiotic germination of orchid seeds, he realized that the seedling contain mycorrhizal fungi. Next, please. And next period was research about pure culture of microbiomes. And for example, Barbara Moss, she was from United Kingdom, was a pioneer British microbiologist. She proved the positive effect of mycorrhizal fungi. And commercial production and application all over the world started in the 1950s and 60s. Researchers proved that mycorrhizae significantly improved phosphorus uptake. This laid the groundwork for using fungi as biofertilizers. The primary method for producing mycorrhiza inoculum during these periods and for many years following was the use of trap pods or pod culture, which involve growing host plants in soil infected with spores. Next slide, please. And also the birth of the industry also all over the world was period from 1970 to 1990. The first small-scale commercial applications appeared in the late 1970s, primarily targeting high-value horticulture and land reclamation. And next, the last period was industrial scalability, 1990s, and to present the start of mass market commercial production. Occurred in the 1990s as biotechnology companies developed in vitro. In vitro, it means laboratory-based cultivation methods. This allowed for clean inoculants or pure culture, diverse formulations, and integration with sustainable agriculture. Next slide, please. You can see also last studies, last researches about molecular genome, and you see genome of Rhizophagus irregularis. Next slide. And very famous Springer Nature link. You see modern books, modern scientific books about arbuscular mycorrhizal fungi, and today commercial production focuses on the highly effective genera Glomus, Rhizophagus, and other that provide broad spectrum benefits to crops. Thanks a lot. Thank you. That's
Thank
all.
you very much, Vera. And while Yaroslava is starting the slides, I just want to kind of summarize it. Mycorrhiza is known at least for 150 years. First 100 years was a lot of work of scientists to understand better what is mycorrhiza and what it can do. And then scientists and industry was working on production method and possibilities, and again, perspective of application of mycorrhiza on different crops. And only recent 30, 20 years, really industry begin to apply it widely in industrial production. So now we are on the stage of active mycorrhiza application, and we again believe that in the nearest 15 years it will grow a few times. So that is why we are happy to be part of this movement. Yaroslava, giving you the word.
Thank you. Hello, everyone. I'm Yaroslava Bukhonsk. I'm a plant physiologist at BTU, and I'm so happy to see you all. So nice to see so many familiar faces. Thanks, everyone, for coming and, of course, listening to us. I hope it will be useful for you, as I will be talking mostly about the biological side of mycorrhizal fungi and mycorrhiza as a symbiosis itself. So let's start. First of all, I'd like to tell you that mycorrhiza is not a novel invention. It wasn't born yesterday. According to scientific research, the most recent data, we can track mycorrhiza symbiosis back to 400 million years ago. So basically, mycorrhizal fungi were there on Earth when just first plants were entering our planet. 400 million years ago, there was no soil on our planet, so mycorrhizal fungi were assistant for plants to colonize this hostile surface. Actually, they were replacing roots for them, and this symbiosis has successfully thrived till modern times, and it is still benefiting modern plants a lot. Next slide, please. As I've previously mentioned, 400 million of years of evolution is quite a long period, and during this time, several types of symbiosis have evolved. And now I would like to tell about two of them, which are most widely spread in nature. So these two types of mycorrhiza symbiosis are named ectomycorrhiza and endomycorrhiza. The most important difference between them is that ectomycorrhizal fungi do not penetrate root cells of plants, while endomycorrhiza are called this way because they penetrate into root cells of plants where they form specific mycorrhizal structures where they exchange nutrients and water with plants. Speaking of plant association spread among plant species, I would like to tell you that 80+% of total plant species on Earth are able to form endomycorrhiza, while approximately 2% of plant species also depend on ectomycorrhiza. If you are familiar with forest mushrooms, especially boletus mushrooms, most of them are forming ectomycorrhizal associations with forest trees. Next slide, please. Next slide, please. Thank you. On this slide, I would like to focus more on type of mycorrhiza which is most interesting for us as we are speaking of agriculture. It is called arbuscular mycorrhiza. So please take a look at right hand side of the slide and you can see a diagram of plant root dissected, and if you take a look at the right side of this diagram, you can see arbuscular mycorrhiza. As I've described before, you can see some specific structures named arbuscles and vesicles. These structures are formed by mycorrhizal fungi. As you can see, they are penetrating plant cells and forming them inside. And they are using these structures to exchange nutrients. So fungi delivers nutrients and water to plant cells, and plants are given photosynthetic products like sugars, amino acids, organic acids, feeding the fungus. And you can also see that there are many types of mycorrhiza. Some of them are specific to ericoid plants. These are plants from Ericaceae family, like blueberry, for example, which is most popular, I think. Also, there are some types of mycorrhiza which are specific for parasitic plants and orchids. Why we're talking about it? Because some plants, like parasitic plants or Ericaceae plants, and even orchids, they cannot survive without mycorrhiza. Most agricultural crops, they can live without mycorrhiza. They will be less productive in that case, but still they will be viable. But there are some plants, which I mentioned, that cannot survive without mycorrhiza because they evolved in this way that this symbiosis became crucial for their survival. And on the left side of the slide, you can see some key benefits which are provided by mycorrhizal colonization to plants. And the most important, of course, is the increased absorption area of root system. It's quite easy mechanism because due to mycelium growth from the roots of plants, the absorption area of root system is dramatically increased, which means better water regime and also better nutrient availability, especially for phosphorus. Because we know that a phosphorus absorption zone is quite limited. It's very limited. It's a very restricted zone around plant roots, and mycorrhizal fungi allow us to increase the zone of phosphorus absorption. And we all know that phosphorus is highly important macronutrient for plants. But it's not only phosphorus, you can see also other mineral nutrients which are also better absorbed with the help of mycorrhiza. And another very interesting aspect, which is not directly connected to water or nutrients, is increased resistance. Because during this symbiosis, this interaction of plant with fungus, some biologically active molecules of fungus are constantly triggering plant resistance, making it more tolerant to abiotic stress, including drought, low temperature, high temperature, salt stress, and also making it more tolerant to biotic stress, meaning pathogens. Next slide, please. Here I would like to tell you that you cannot see mycorrhiza with a naked eye. I'm talking about endomycorrhiza. It means these structures can be seen only inside of plant roots. And of course, we are using some special microscopic techniques which allow us to visualize these structures. So to do it, we need special dyes, which are interacting only with fungal structures. So you can see on the left side root of sunflower, which is not mycorrhized, so no fungal structures. We see transparent cells, and on the right side you can see some blue structures, which became blue because they are of fungal nature, and that's how we can prove that this root is mycorrhized. And visually, like, it is not forming any fruiting bodies on the surface like you can see in the forest. No, our endomycorrhizal fungus don't do it. Next slide, please. And speaking of plant stress tolerance, I would also like to add that mycorrhiza increases plant stress tolerance not only because it improves water and nutrient uptake, even though this mechanism is very important because mycorrhized plants, they receive a competitive advantage comparing to non-mycorrhized plants because they have increased photosynthetic activity as well. And talking about specifically plant stress tolerance, we know that after the symbiosis, plants have increased antioxidant accumulation, which makes them more resistant to any type of stress. And mycorrhizal fungus itself increases soil water holding capacity because mycorrhizal fungus are forming specific compound glomalin, which is known for binding soil particles and binding kind of water in these particles. That's why improving this characteristic. Next slide, please. And a few words about our product, MycoFriend. It's available in two formulations, in liquid and dry formulations, and that's why there are few application methods. depending on the formulation. For dry formulation, we recommend to apply it as a seed treatment directly in the seeder, and while liquid formulations is recommended for application during sowing via in-furrow application. Also, it is compatible with liquid complex fertilizers if anyone is using this technology. And we also recommend it for seed treatment as a liquid formulation. Next slide, please. And what is very important to know is that our MycoFriend is a complex product because it contains not only mycorrhizal fungus Rhizophagus irregularis itself, it also contains composition of other fungi and bacteria which are native to rhizosphere, and they stimulate plant root system growth to ensure colonization, because mycorrhizal fungus spores, they germinate only as a response to plant root exudates. So we need to have strong and healthy root systems which are producing enough amounts of exudates to trigger germination of mycorrhizal fungus spores, and therefore to ensure mycorrhiza formation. Next slide. And of course, we all know that mycorrhiza fungus, they are living creatures, and of course there are some factors which are negatively affecting them. And obviously, pesticides, especially broad spectrum fungicides, are detrimental for mycorrhizal fungi. Also, some agrotechnical operations like deep tillage negatively affects mycorrhiza, as well as introduction of fallow, because mycorrhiza is living only on living plant roots. So if we have no plant roots in soil, we have no mycorrhiza. And there are also some plants which are not able to form endomycorrhiza. They are representatives of few families, including Amaranthaceae, including sugar beet, Polygonaceae, including buckwheat, and the most aggressive mycorrhiza killers in the soil are Brassicacea, seed, and other members of this cabbage family. Next slide, please. The problem of Brassicacea is that these plants are producing isothiocyanates. These compounds are strong fungicidal compounds which are used as biofumigants in the soil. That's why some farmers are growing radish or mustard as cover crop or green manure, because they want to kind of biologically sterilize their soil. And the problem is that not only pathogens are killed in this way, but also beneficial fungus are suffering, including Rhizophagus, which is forming mycorrhiza, and Trichoderma. That's why it's very important, after having a Brassicacea plant or any crop of this family in your crop rotation, it's essential to inoculate with mycorrhiza fungus the next crop, because you will probably see the negative consequences, especially including phosphorus deficiency. It's quite widespread situation in corn if it is planted after rapeseed. So always keep it in mind. And that's it from me for today. I hope it was interesting for you to hear some biological facts about mycorrhiza. Thanks everyone for your attention.
Thank you very much too. Just want to say to everybody that if you enjoy Yaroslava's speech, you also can always return to her online in YouTube because we have available some recorded videos about mycorrhiza and also some other uh,
Biological
microorganisms.
agents, yeah. Oh, yeah. It's a series about microbes, which are biological agents in our product. So you're welcome.
Yeah, and on this, I would like to ask my colleagues from the agricultural team to switch on the presentation, and we will continue with more, even more practical slides about our experience of using mycorrhiza in field crops and horticultural crops. Yeah. Dima
Hello
is
everyone. So, yeah, 1 second, please. I just have a small technical question.
I think that nice green sunflower on your phone is also mycorrhized, as well as my soybean. Please proceed.
Hello everyone. My name is Dmitry. I'm agronomist of BTU from international department. And my part of this presentation, it is about our experience with the partners, with a lot of countries for arable crops with MycoFriend. As you already know, after speeches of my colleagues, we have a two formulation of MycoFriend. Uh, it is powder and also it is liquid formulation. As you already know, for liquid formulation, we have a rate for application for the seeds from 1.5 until 5 liter per ton of seeds. If you want to use this and you have a possibility to use this product for system and for all, a rate will be from 200 until 300 milliliters per hectare. And for dry formulation of mycoplant, our recommended rate is from 1 until 8 kilogram per ton. It depends on for what crops we use this product. And also, my colleagues Yaroslava and Vera already shared information that we can identify this mycorrhiza under a microscope, but you can see how it looks on the practice. What influence for on the plants has a mycofriend. So visibly we can evaluate amount size of root system of plants, better development of vegetative mass, and also better adaptation of plants on the, for example, new places for plantings. Also, we have a general recommendation for all crops. As you see, we have for arable crops, for vegetables, for trees. We use this product for seed treatment, for application for root system, and also for system drip irrigation system. We have a lot of questions from new partners, from new farmers who wants to use this product. And let's start from powder. As you see, we have such packages of product. As you see, it is like first protection of our products against some storage conditions, storage conditions. And second one, it is like plastic under vacuum package. When you provide a when you open first package, you must to make a small hole in plastic to provide penetration air inside of packages. After that, we just blend or mix a little these substances which we have inside. After that, and also very good positions that this formulation of microfriend we can use directly on the field. As you see, we can use it directly to the seeders to provide mm, some amount of product inside of each jar to mix a little by your hand or other tools to mix a little, and after that you will ready to sow. If we're talking about liquid formulation of product, you can use usual equipment for that. It is like complex, a standard complex for big quantities, a little for big quantities of seeds for treatment. Second one, it is like screw dressing machine, and in process of a lot of these seats on the some tank or car, you can apply microfriend. Uh, Number three, it is a very similar process like previous one, but with a little bigger amounts of seeds. And last one, when you use the system in row, and also you can use this liquid formulation on microfriend directly in the row during sowing. And next one slide, it is like our practice with pit form of microfriend on some liquid and pit form on sunflower from 2019. As you see, we used the same rate per ton of microfriend. For pit formulation, it was 7 kilos. For liquid, it was 7 liter. As you see, I think for everybody is interested in what results we received. As you see, both formulation provide us better result in comparison with control, and very similar uh, yield provide all formulations.
Dima, if you don't mind, I would like to add to this slide. Very important is also here there was a kind of protection system, and probably seeds were also protected because quite often we receive questions about compatibility if seeds are already protected with chemical fungicide. So in most of our studies, we have such a seeds because you almost cannot find clean seeds. So in most cases, we don't have problems with chemical protected seeds.
Correct. Thank you.
You can continue.
Thank you. And also, small statistic about experience trials with microfriend. As you see, we have more than 50 trials with microfriend. Very high percent with successful of these trials. Average income was around $50 per hectare. Maximum was 150. And as you see, average increase in the yield was 0.17. Maximum was half a ton. Also, it is, I would like to draw your attention that these results on this slide, we have like average during 5 years. As you see, also with different background of fertilizer, was better result with microfriend. For example, without fertilizers, where we use the microfriend 5 liter per ton for sunflower, these applications for the seeds provided us plus 0.17 tons per hectare. where we use the mineral NPK 40-40-40 with the same rate for seed treatment, provided us the same increase in the yield in comparison with control, 0.17 tons per hectare, and also where we had organomineral fertilizer scheme like NPK 40-40-40 with the same rate of mycopren provided us more than 100 kilos increase in the yield. And also, I would like to ask you to calculate how many grams per hectare of mycopren you spent in this trial. For example, if you can provide from 1 ton of seeds around 50, 80 hectares, it means that you spend 100, 150 grams of mycopren per hectare. Also, one more trial with different years. As you see, also I would like to draw your attention on these two scheme of trials where we use the ground fix. It is also our products, phosphorus and potassium mobilizer for soil treatment. And also we provided seed coating by mycopren 7 kilos per ton for each year, and will be better to see this result. In average, during 4 years, we received plus 0.28 tons per hectare, and where we use the only mycopren 7 kilos per ton, this application provided us plus 0.26 tons per hectare, increasing the yield. Next one also trial where we use the mycopren for system in furrow together with diaphan. It is like mineral fertilizer, liquid mineral fertilizer, liquid complex fertilizer, which we used in period of sowing. And mycopren, we used only 150 milliliters per hectare. This application provided us plus 0.25 ton per hectare increase in the yield in comparison with control. One more trial, it is already from Moldova. As you see, they also, our partner, Vitrate company, used the mycopren plus ground fix plus liquid fertilizer for the sunflower with these rates which you see on the slide. And also you can see in comparison with control, better development of plants, root system, and also vegetation mass. Efficiency of mycopren on corn. As you see, we have around 87 trials. Application of mycopren for seed treatments of corn provided us income in average 45 euro per hectare, dollars per hectare. Maximum it was more than plus 300 dollars per hectare, and average increase in the yield was 0.27. Maximum was a little less than plus 2 tons. Also, as you see, for in average rate for the seed treatment application for seeds provided us in average 0.33 tons per hectare. When we use a mycopren for system in furrow, can provide us in average 0.22 tons per hectare, increasing the yield. Also, it is already our own photo from our labs As you see on the control, on the root system from control place, we don't have the same good creation of vesicles and arbuscules in comparison with the root system where we use the mycopren 5 kilo per ton. If we calculate per hectare, it means we use the 100 grams of mycopren per hectare. And also you can see on this photo what result we can have. One more trial from Ukraine, the same on the corn. As you see, we make this trial during 5 years, and every year Mycopren showed us very similar result with phosphorus and potassium mobilizer. And in average, during 4 years, application of Mycopren for the corn provided us more than 1 ton increase in the yield. One more trial with Mycopren on the corn, and also I would like to draw your attention that application of microfriends on the seeds was uh, uh, 2 weeks before sowing. It means that you can provide application of microfriend. Okay, you can apply microfriend on the seeds and to sow that during few weeks after applications. As you see on the second photo, we have a result after application of mycopren, and you can compare that with other analogs of products. It is one more fresh trial from the Moldova where we use mycofriend for seed treatment, and also there was such conditions that we applied mycofriend 5 days before sowing, and you can compare better development of root system with a control uh, with a plant from control place. One more, few more trials. It is from research station from Germany. It was in 2023, as you see, where we use the liquid formulation of mycofriend with the rate 1.5 kilo per ton for winter wheat. And these applications for seeds provided us 11.8 ton per hectare in comparison with control. On the control was 11.34 quantity of yield. And also we checked the efficiency of mycofriend powder with the same rate 1.5 kilo plus one application during vegetation period with our stop stress program, like three other products. And also this scheme for winter wheat provide us increasing the yield in comparison with control.
Just also to add a small comment, Tima, if possible, on that study.
Yeah.
You can see that it's winter wheat and yield is quite very high because in Ukraine normally we have lower, like 7, maybe 8 tons per hectare, and here even on control we have more than 11 tons. So even for Germany it's quite high, but still in these conditions Mycorrhiza could provide even more. So it's really is not so limited even in such conditions.
Yeah, and also mycorrhiza works not only on the poor soils. As you see, humus content was 4%. Also, it is like first studies our trials in Germany with this product. Our farmer, used the 5 liter of Mycofriend for the seeds, and these applications on the corn provided us plus 0.8 tons per hectare increase in the yield. Also, we have a partner, friend, colleague in Germany, Andreas Schmidt, and this trial is from his practice. And may I ask Andreas to comment this trial?
Yeah, I can do for sure.
Andreas,
So,
hello.
yeah, in this trial, we used Mycofriend on maize. We tried to use it on biochar or as a seed coating. So there were two different application methods. First, we used like biochar. We put vinasse on top, and then we also used Mycofriend. We mixed it very carefully, and then we put it in the furrow. So during seeding, there was like a second line with biochar inoculated with Mycofriend. That was one treatment. And then we had another treatment in which we used the same seed, but like which was not seed treated. And then we put Mycofriend on top. And then we also put it in the soil. We could see that there was like a good good root development, and there was like a good biomass accumulation. Yeah, we also had like a drone that kind of analyzed the vegetation, and yeah, but unfortunately the quantity amounts are still pending. But yeah, from the first perspective and the impressions, there were good root growth and good biomass accumulation at this point.
Nice. Thank you. And I think I can add that if you have a wish to use Mycofriend, we can discuss how we can think about application together and how we can adopt to make an adaptation of this product for your system of application. And also, I think from my side, it is all which I wanted to share today. And may I ask my colleague to continue presentation?
So, while our colleague is switching on the microphone, I just comment, we continue the field practices with some other crops, some cereals and legume crops. And after that, we will also have some studies on horticultural crops. So, Alexander, are you with us?
Yes, do you hear me well?
Yep.
Yeah, hello everyone. My name is Alexander Rontsevich. I'm a leading agronomist at BTU, Biotech company. So we will continue with the cereals and legumes in the next slide. So from our database, we collected certain amount of trials to see the efficacy of Mycofriend on cereals. At the data we collected, we have numbers like around 80% of successful trials with the average boost of the yield from 260 kilos to more than 1 ton per hectare, which provide us like a very good economical numbers from around $50 to more than 200 earn from the hectare of cereals. So on the next slide, we see that we try to test Mycofriend at different backgrounds. It was done in Ukraine in the Steppe Agriculture Institute. So during the 5 years, we see that when we test Mycofriend at the rate of 1.5 liters per ton of seeds, we have a consistent and I would say repeatable boost of the yield in different variants without fertilizers, with mineral NPK and with organomineral NPK backgrounds. So it's the numbers varied from 370 kilos to more than 450 per ton cereals. The next trial we see, the idea was to see the efficacy of MycoFriend together in the mix with the liquid complex fertilizer, especially when we apply it in the in-furrow method, because the idea is to see how this combination provide immediate availability of nutrients to emerging roots and promoting early growth of the crop. So we see the scheme was the control site with the farm technology and liquid complex fertilizer, and two variants with a different dosage of MycoFriend with liquid fertilizers. We see that what the number is that we have a very good boost of the yield around 770 kilos per hectare from variants in comparison to the control site. We also, sorry, can you come back? We also did some NDVI analysis of the treated plots, and we see a very big difference in color changing between the control and tested plots. So here we have made a trial at the Rumakai test station with a ground fixed MicoFriend. We just the idea was to compare the Mycorrhiza to the phosphorus solubilizing byproduct and to the standard local farmers scheme. We see that under the Baltic state conditions and fertilizer background, MicoFriend showed impressive yield boost. You may see on the screen it was made by 1.5 liter per ton of seeds. We see that the application increased the number of the amount of grain per spike and weight of 1,000 seeds in grams. Next slide was done together with a farmer in organic scheme of winter wheat. We see that when we apply a product at the rate 1 kilo per ton of seeds, we still have an economically good result. We also see that the combination of the MicoFriend with other biologicals from our portfolio even I would say enhance the boost yield in a good way, provide us a better better economy from the field. Here we tested MicoFriend in Slovakia, where we measure the biological yield. Maybe Dmitry can comment.
Just would like to add a small joke. If you follow us on LinkedIn, probably you have seen me on this field a few days ago, because it's a kind of traditional field studies place for us in High Tatras. This field is on the height of 800 meters. And together with our partner Organics, we have plenty of studies over there. But more or less, yeah, Alexander, you can continue with the presentation.
Yeah. So yeah, in general, it was a small, as Dmitry said, it was a small tested plots at the site.
Sorry.
Let's continue.
Still, I would add a few words then. Could you return the slide, Dima? So yeah, so the specific of these fields, as I mentioned, is it's quite high on high altitude, and conditions there are quite more stressful with temperature changes over night, and in general, that is why again we see that Mycorrhiza in these critical stressful conditions helps plants to develop and provides quite high contribution to the yield. we can continue.
Yeah, let's continue with legumes. From our collected data, we see a good efficacy of MicroFriend on legumes, including soybean. So from the data collected, we have around 86% of successful trials with legume crops, and also impressive numbers from 200 kilos to 800 kilos per ton of hectare ton per hectare. Yeah, ton per hectare. So it's also give us a very good income from around 87 to more than $300 per hectare in general. So MicroFriend also have tested together with Frisoline to see the general idea was to see if the co-inoculation can improve the nodulation, root development, and grain yield. Here in Ukraine, we made a 5-year study in the Steppe Agriculture University together at different backgrounds, so with no fertilizers, with mineral NPK and organomineral NPK, different dosages. The general scheme was 2 plots per background control, and in comparison to the MicroFriend, 1.5 liters per ton, and Rizoline together with Rizosave at 2 liter and 1 liter dosages respectively. So we see the average numbers varied from 90 kilo to more than 200 kilos per hectare of the yield boost. Another trial together with our partners in Slovakia on soybean on the east. We see that when we apply MicroFriend 1 liter per ton of seeds, we may expect what we see on the screen. So the plants from the treated plots have a thicker stem and a better leaf development in comparison to the control plots, where we see that plants just crossing this BBCH stage to have more vegetation development area. I mean zone of vegetation. Another trial with a MicroFriend, but now in Uzbekistan from last year, where we tested MicroFriend on soybean. We see that we collected the soybean pods just to see if we have a difference in number of pods, in the size of soybean grain, and we saw very impressive production capabilities of plants treated by MicroFriend. As you can see the screen, you can count how many pods and imagine the potential yield boost from that application.
Well, thank you, Alexander, for this overview on soybeans and cereals. And I would like to ask our colleague Serhiy Drab, who is our horticultural specialist, to show us how we can apply mycorrhiza on horticultural crops.
Hello, everyone. I hope you hear me. Most of you know me, but still I will introduce myself. My name is Serhiy Drab. I am horticulturist at BTU company. And today we will speak about horticulture crops and some vegetable crops. So enjoy. Next slide, please. Let's begin from our trials with MicroFriend in Germany on potatoes. So mostly we want to pay your attention on yield, of course, but still we want to pay attention on the second table with the quality parameters. So now I want to show you that due to bigger yield, which we received with using MicroFriend, we receive as well the higher amount of starch. As we know, the starch for now cost from 1,000 till 5,500 euros per ton. So if you will receive 0.8 tons, that's incredible results, and you can calculate that you will receive good profit for given potatoes on to make starch. So we can go next. Next as well, potato, but sweet potato. It's a very modern and innovative crop in Europe. We saw that on all exhibitions there are a lot of companies which produce sweet potatoes. So here, please pay attention on tuber yield. So yeah, we receive some increase using MycoFriend. We use MycoFriend in this case. We were using it in fertigation with amount 1 liter per hectare. Of course, some of you maybe you don't have fertigation, but still we recommend to make some, let's say, tuber treatments before the planting. As well, you can see that, as I told you, the quality parameters, you see the increasing of starch level, vitamins, and total sugars are much more higher than on a control part, where they don't use any products. This trial is, can you back? Yeah, this trial is it is 2 years trial. That's why you see that it's more complicated data, and this is like average parameters which we collect in 2 years. Yeah, we can go next. Also interesting crop is garlic. That trial is very interesting because we have two different applications, two different variants with different applications of MycoFriend. So first of all, we make, let's say, seed treatment, yeah, with MycoFriend in amount of 2.5 liters per ton. And another variant, we use seed treatment, and the second application was with fertigation. We see that two-time application gives better results. And the last variant, I want to pay attention on the last variant, that was chemical seed treatment. And you can see that if we compare chemical products and MycoFriend is on the same level as the chemical product. We see that the yield comparing to seed treatment with just seed treatment with MycoFriend is much more higher, and claw weight are bigger. Claw weight is gives us the understanding that on next year we can use them on the planting of new plots. Yes, we can go next. The carrot trial was done in Ukraine in our national university. So here also was trial was this trial we want to pay attention on the biometric parameters. So you also see the height of the plants, the diameters of carrots, and of course in this case we have like increasing of the yield, very good increasing, plus 8.1 tons per hectare. But also what is interesting, we use MycoFriend after sowing of the seeds, and also in a fertigation. So two-time application gives the better results. We saw it, and you see the last 3 trials we used 2 times application, and we see the good, incredible results. We can go next. Also, we have some trial on sweet corn in Ukraine. We want here to show you that with MycoFriend, the potential of the plant is bigger when you use drip irrigation. That's 100% sure, and you know everyone this. But when you give, when you add some biostimulants, or in our case MycoFriend, which help plant to be more vital, grow better, make formation of roots higher. So we see on the diagrams, that second diagram show us that with drip irrigation we have better results and higher yields, comparing even to NPK and different mineral fertilizers. Because MycoFriend works on a root colonization, and in this case we receive better and more quality yield. Yes, we can go next. That also is very interesting trial. Yeah, you see the different crops. Let's begin from watermelon. So we use mycofriend in a substrate. We give them it 1.5 kilogram per cubic meter of substrate. We see for what reason we do it. We want to make better roots, make them bigger and more vital. In this case, then when you grow seedlings, it will better to have good roots for replanting. We see here the potential, and also the plants are more vital. The shoots are stronger, the leaf area is bigger, and when you replant them, the plants and seedlings grow in faster and give you quicker your crop or harvest. Yeah. And also, what I want to show you, who is dedicated with growing of fruit trees or nurseries. You know that all trees are growing from the nursery, from the rootstocks. And for receiving good rootstocks, you also need to use some rooting agent. And in this case, we recommend you to use Mycofriend, because when you make, there are different ways of growing rootstocks. So there is a vertical method and a horizontal method. And in each method you use as a substrate sawdust, and you make like special cover on the rows. And in this case you need mycofriend to make more roots. You can see the trial plot. There is the same amount of plants, 3 plants on the control, 3 on the trial, but you can see that the difference in roots. When we collect these rootstocks, we even calculate the shoots length, and we receive that in a trial plot we have more shoot length than in a control part. That means that the rootstocks gives more power to the plants and to variety. You can see that we here we can use bigger dosage through drip irrigation of mycofriend. It's 2 liters per hectare, but still we have the increasing plus to 224,000 of pieces per hectare on the vertical method and 32,000 on the horizontal method. Yeah, of course, horizontal method is more usable, but still 32,000 rootstocks per hectare, it's quite big amount. If we compare that, 3.5 thousand plants are in orchard on 1 hectare, so 32, it's quite a lot. That's can you next?
It's I think the last one from
Yeah,
horticultural side.
that was all information for me. Most of you can have my contact. You can contact about horticulture and vegetable crops. We will provide good and very quality technical support for you and your companies. Thank you.
Great. Thank you, Sergey, for the presentation. And I believe that nearest years we will get new and new experience on horticultural crops. By the way, maybe you can show, we had here a colleague from ATS, a company from Egypt, who also tested Mycofriend recently on the grapes, using it in fertigation. And maybe, Sergey, if you can find the slide, you can show it in a few minutes together with Dmitry while I'm continuing the presentation, because it's an interesting one, and maybe if ATS colleague is here, he can also add some words. In process, in parallel, I would like to share with you that we are using, we getting some comments. So for the comments, I would like to say, if you have any questions, please, you can write them in the chat, and after a while, we can return to them to answer together with our experts and specialists. And we have just a few minutes left. Yeah. Using of Mycorrhiza is actual not only in the professional segment, but in home and garden. Probably you know that we have also a few brands of home and garden. In Europe, its main brand is Healthyland. And we are proposing, no, we have a lot of content about mycorrhiza and a lot of people active in growing some vegetables and some plants at home. Already hear a lot about mycorrhiza because very often, again, when you start searching something about biologicals, you first of all find a lot of studies about mycorrhiza. And that is why, again, when you type mycorrhiza in YouTube or somewhere, even on TikTok, you could find already a lot of content, including some content with MycoFriend. And this year we are launching MycoFriend product in small packaging in Europe. Sometimes it's used to home and garden, but sometimes we also discuss with some partners who sell seeds in some small packaging that this pack is also sufficient, for example, to sell together with corn seeds or sunflower seeds. So you also can consider this as kind of additional business model. So on that, maybe I will give a word to Maria. Maria, are you with us? To show us some
Hello.
material content.
Hello, everyone. It's very nice to see you. Thank you for everyone for joining our webinar. I have just one slide. I want to tell you about our PDF materials about Mycorrhiza and our product MycoFriend. We will send you after the webinar within 1 or 2 days, so you can receive a good files with complex information about our products, about our solutions, about our testings. And our last part of this webinar is a little bit entertainment. It will be a quiz from Kahoot. So we would like to invite you to participate. Please, Alena, can you expand? Yes. For those who first time joining the Kahoot, it will look like that. You will read the questions on the screen at your laptops or computers, and you should answer. You should choose the variants on your telephone. And also I want to tell you that we have prizes for the three first winners. It will be a branded desk. It's like a notebook for notes. BTU with branding BTU, and also telephone stand. And the third one, it's like a desk pen holders. So please be ready to join and answer promptly. Every second counts. And wishing you a good luck. Alena, we can start.
Think we can comment the questions while we're waiting. So the first one is mycorrhiza can enhance the effective root surface area of plants by dozen of times. So how do you think it's true or false? So all of you are right. So I think we could already see the potential three winners of our quiz, but still let's continue and see what are the questions we have here. So which nutrient uptake increases the most with mycorrhiza? Potassium, phosphorus, calcium, or sodium? How do you think? So again, we have all correct answers. Be attentive, times also matters. So next question is, which mycorrhizal fungus is included in the MycoFriend product? Fusarium, Rhizophagus irregularis, Alternaria, or Cladosporium? Oh, you're serious? Fusarium? It's not. We have Rhizophagus irregularis. So what is the main reason why mycorrhiza increases plant drought tolerance? Fungi produce water, fungi block transpiration, EFA penetrates small soil pores that roots cannot reach, and mycorrhiza reduces plant growth. Oh, somebody give us a help. Yeah, you are right. So next one. All plants are capable of forming mycorrhizas association. True or false? You can remember the Vera Borodai's presentation. Also, in presentation of Yaroslava, she mentioned some special plants after which even you should inoculate your seeds because, yeah, indeed, there are plants which are not forming mycorrhiza. Which mechanisms allows mycorrhiza to improve phosphorus uptake? Secretion of enzymes and organic acids, conversion of nitrogen into phosphorus, interesting. Uptake of atmospheric phosphorus, even more interesting. Or blocking mineralization. I hope you have some fun with these variants. Sorry. Pesticides may negatively affect mycorrhizal fungi in soil. How do you think? Is it true or false? You're right. But still, somebody didn't, I would say. So the third place has Jan. As far as I see, Jan is representing To-Speak company. Second place, Nicholas from Lebanon, and the first place, Just Greece. I think it's our friend and colleague from UK. So congratulations. We will contact you after the event to organize you with presents, right, Maria?
Yes, I have request for our winners. So please share your WhatsApp number in the Zoom chat so we can contact you regarding the prizes.
Otherwise, we will write you an email,
Yes, of
which
course.
you have in which you filled in registration form.
Okay.
S-
I would like to thank you for this lovely presentation you did. All the group you did that, and thank you for giving the opportunity to make this quiz. It was very interesting, and the presentation was very interesting. It's not because I won, but it's just really interesting. So thank you very much, and hoping to perhaps we can begin business together. Okay, thank you.
Very much appreciate your kind comment, and we are at your disposal to continue the discussions after this webinar. So just as I mentioned, I would like to share one more example, which made in made in Egypt. Sorry, the quality is not maybe perfect, but still it was quite interesting for us experiment applying mycofriend in fertigation. Last year, our partner observed better kind of shoots development on the trial plots. And what was especially interesting about this trial is that this plot more or less was planned to be removed, but after the study, on the trial plots, they decide to leave it for another few years, which shows sometimes biologicals helps you to kind of prolong the productivity of your orchards. Besides that, 1 second, I just want to stop sharing. Do we have any questions in the chat? We have some contacts data. So still you have time to ask some questions. Well, while you are doing so, I would like also to share some comments that still we are not surprised but happy that online format continue its life after COVID times. And because even after our last webinar on in October about liposome adjuvant, by the way, you can organic adjuvant, you can find its recording on YouTube or ask us, we will share it with you. On that webinar, we had representatives from 18 countries, and today I had counted 22 countries present here. So we had 10 representatives from Europe, from countries like Slovenia, Cyprus, Germany, Austria, Bulgaria, UK, Spain, Hungary, and Greece, and also Ukraine. Also, we had 7 countries representatives from Middle East and North Africa, like Morocco, Algeria, Egypt, Tunisia, Lebanon, Jordan, and Turkey. We had few other African countries like Kenya and Zambia. We had a representative from India, from USA, and also from Ecuador. So we have quite a representative and respectful group here today. So we will continue this format in nearest future. By the end of next month, we plan another webinar about management of abiotic stresses, especially of drought. Also, maybe we will touch a bit salinity problems and some soil conditions like soil degradation, fatigue, etc. But mainly we will speak about drought. So keep following us, join our LinkedIn group, contact us via email or in groups in WhatsApp. Our team is always happy to communicate with you, write questions, and yeah, we are at your disposal. So again, on that, if nobody have questions, let's finish our webinar today.
Thank you.
Thank you very much for participation, and thanks to the team for organization of this event today. All the best.
Thanks.
Bye. Thank you. Thanks everyone
Thank you,
for
bye.
Thank you, dear friends.